Welcome everybody to the next video of computational thinking in IGCSE. So in the previous video we discussed about searching algorithms. In this video we are going to talk about sorting algorithms. Sorting is very important in computer science, okay, because when the data is sorted, many operations can be done much faster and more quickly in computer, okay. So it is very important. So we are going to study some thing about sorting, okay. So see, in unsorted data, if you just want to do some search, if you want to find anything, that would be just very difficult. But in sorted array, that we have studied, finding elements and performing many operations will be very systematic and easier, okay, as we discussed in the previous video about linear search and binary search, okay. Binary search is much faster than linear search, but yeah, the data has to be sorted for that. Simply, sorting is a process of arranging data into a specific order to allow computers to find items instantly. Simply, order equals speed, okay. So when just there is a speed, then and our goal is to just make programs to work faster in computer, okay. So searching unsorted data requires checking every single item, okay, which is just a linear search. But when it is sorted, ordered items allows for highly efficient searching, which is binary search. So sorting is very important, and we have to just think about different ways to be able to sort unsorted data. See, what is sorting algorithm? Okay, sorting algorithms are designed to arrange data into a specific order, enabling faster searching and better organizations. So we can sort elements in ascending or descending orders, okay? Smallest to largest, like 0 to 9 or A to Z, okay? And descending order Z to A or 9 to 0, okay? We can just sort elements in any of these orders based on our requirement. See, the algorithms that we are going to study here are bubble sort and merge sort, okay, and we will just compare them how they are. So bubble sort is the brute force for sorting, okay. So here bubble sort repeatedly steps through a list, okay, repeatedly steps through a list. It compares adjacent elements, okay, it compares these two elements, then it compares the next adjacent elements, the next adjacent elements, and if they are in the wrong order, it will just simply swap them, okay, it will make them in the correct order. So there is comparison, okay, comparison starts with the first two items, then after that, yeah, second two items, then the next two items, the next two items, comparisons are done, okay. And what is our decision here? Swap if order is required, okay. And bubbling, when you just finish one pass through all the elements, okay, the largest value will bubble to the end, okay, it will just get to the end. So comparing all the elements one by one, okay, the pairs of elements from first till end, that is called one pass. And in one pass, only one value just gets to its correct position. In see, mechanics of the pass, the algorithm completes a full traversal of the list from first till the end, comparing every adjacent pair from start to finish. Okay, this is called a pass. So comparing two first, then the next one, then the next one, then the next, till you just finish that, okay. And at the end of one pass, one element just surely gets to its correct position, okay. So that is one pass. Then the golden rule of termination in bubble sort, okay. A computer must rely on a strict logical condition to know when to stop running the loop. So here, what is that strict logical condition for bubble sort, okay? That is, sorting only stops when a full pass is completed without a single occurring of swap, okay. One complete pass is just done, pairs of elements are compared one by one from first till the end, and no swap was needed, no swap occurs, okay. Simply that means the data is already sorted. So if no swap occurs in one pass, then that data is sorted and we can just simply get out of the loop. So talking about the efficiency and limits of bubble sort, okay. Bubble sort is a brute force method, and in this you will compare elements one by one. Okay, two first elements, then the next two elements, the next two elements, the next two elements, till you get to the end of that. Okay, and doing this, which is called one pass, one element will get to its correct position. And for the next element, again, you will have to start from the two first elements, then just you have to do it till the end. For the next element, again, you have to start from first till the end. Okay, so you will have to just do the comparisons around n by n times n to the power of 2 times. Okay, so the efficiency of this algorithm is n to the power of 2. Okay, n by n. And about the good things and bad things about this, okay, it's simple to write and understand. It is quite straightforward, but for large data or data set, it becomes very slow. Okay, so it is not very efficient for large data. It might take days to just perform some calculations on this. Here we have gotten the pseudocode for bubble sort. Okay, in which, as you can see, okay, we are just having a for loop starting from 0, okay, going up to n items minus 2. Okay, because the two lost elements will be compared, so I do not have to just go to the lost element, because I have to have something after that to compare. So just that is a loop. Okay, then swapped is equal to false, so we will just make it false if this inner loop completes and this swapped does not change here. Okay, so simply it means we did not make any swap and the list is already sorted, so we will just get out of it. Okay, and inside this, see, inside our main loop, we have gotten another loop that again starts from 0, okay, and goes up to number of items minus I minus 2, and in which we just simply compare the two adjacent items. If needed, then we will just simply perform a swap. Okay, this is the code for swap. You may just stop the video and just look at it, what is just happening. Okay, here simply we are taking a temporary variable, storing one of the values inside that, then change the value of the that, and the temp will be just stored in the next one. And see, because a swap happened here, we will just change swap to true, then end if next j. Okay, we will just go to the next item. See, when this happened, we are just checking inside the for loop, the main for loop. Okay, if swapped is false, it means it did not change to true here, then exit for. Okay, exit this for, it means our data is already sorted. So once again, you just you may pause the video, you may just watch this very carefully and try to analyze this for yourself. The next thing that we are going to discuss about, or the next algorithm, is merge sort. Merge sort is divide and conquer. Okay, to sort massive data set efficiently, merge sort breaks the problem down into manageable microscopic pieces. So here we break the large data set into smaller pieces till we just get to 1 elements each. Okay, and we will just then merging them back, we will compare them and just put them in the correct order. Okay, in your exam you might just have a question on recursion. Okay, what is recursion? A recursion is a process that is repeatedly applied, or simply this is a function that calls itself inside it. We will just make a function, and inside the function you will just call the function again. So we just create a function to divide a data set into half, then on each half again we will call the same function to just half it again, just it will call itself. So repeatedly it will just happen. Clear? Then see phase 1, the splitting phase, recursion. Okay, here we will just call the split function, and we will just split the main data into 2 smaller data sets. Okay, then we will just keep dividing them until we just get to 1 element, which is sorted by definition. Okay, 1 element that is just already sorted. Then while merging them back, we will just compare them. For example, 8 and 4. Now I'll compare 8 and 4. So 4 is smaller, so 4 has to be here. Then I'll put 8 there. The same thing I'll just do here. 2 and 6. So yeah, 2 is here and 6 is here. That's correct. I'll do the same for the rest. And after that, yeah, comparing these both to just make the next one. Okay. In the next slide, we will just talk about that. See, phase 2 is the merging phase. So sublists are reassembled in ascending order. The algorithm only compares the leftmost items of the list it is merging. So see, the algorithm compares 4 with 2, okay? 4 with 2. Whichever is smaller, it will just go to the next position, okay? So see here right now, we are comparing this element with this element. And these both are just the indexes, okay, that we have stored. So 4 into 2 is smaller. Okay, so 2 will be just stored here, and because 2 is just stored, we will go to the next element. Now 4 and 6 will be compared, okay, and between them 4 is smaller, so 4 will be just placed in the next position, and because this is also just done, we'll go to the next one. 6 and 8, so 6 is smaller, okay, and after that simply we'll just come to 8, and we have just finished that, okay. So that is how merging happens every time when we are just merging elements. Efficiency and trade-offs, okay. So efficiency of this algorithm is quite good, okay. We have gotten n log of n. Log n, why? Because just every time you divide the list by 2, so dividing by 2, for example, if you have gotten 10, so it will just take 3 or 4 steps to just make that, okay. And in each one, in each step, you're just comparing all elements again, okay. So that will be n log of n. That is just the speed of this. Then but the trade-off of that, it just has high memory consumptions, okay, because it is not sorted in place in the memory where it is, okay. Every time when you are just splitting the data set into smaller ones, you are creating a copy for the sub lists, okay, and that creating copy needs extra space. So it is very high speed, but it has high memory consumption, okay. So bubble sort and merge sort, if we compare them, so bubble sort is brute force, repeated passes, okay, every time, and merge sort, that is divide and conquer, okay, recursive splitting. Memory usage, bubble sort is very low, okay, because it sorts the elements in place, but memory usage, merge sort, is high because it requires additional memory for copy of arrays, okay, or for arrays. And speed at scale, speed of bubble sort is very slow for large data, okay, but merge sort, it is just quite fast, okay. Compare the graphs. As data increases, the amount of work or the amount of steps it just needs to perform increases a lot, okay. But in merge sort, yeah, that increment, our data increases very fast, but the increment of our operations is just not too much. See, exam hall strategy, there are just some things, okay. When tracing an algorithm, you must prove your computational thinking by showing the progressive intermediate stages. So there is one thing, okay, you will be asked many questions that, yeah, this is the original data and we are using, for example, bubble sort, show us the passes, okay. See here, it has not asked us the steps, it has asked us the passes. So when just one complete pass finishes, what happens in the data. So the steps you can do on some other paper, then here you have to just write the passes, okay. Always show the state of the list after every pass, and do not skip straight to the sorted value, so pass, okay. So once when just we start from 3, comparing 3 and 7, so no sort needed. 7 and 4, yeah, sort is needed there. Then 7 will be here, 7 and 8, no sort needed, and 8 and 9, no sort needed. So see here we have gotten 3, 4, 7, 8, 9 at the end of the first pass. And in the next pass again, 3 and 4, no sort needed, 4 and 7, no sort needed, 7 and 8, no sort, and 8 and 9, no sort, okay. So no sort happened till the end, our data is already sorted, okay. And remember that include the final pass with 0 swaps to prove termination. So now our termination is proved, so we will just get out of the loop, okay. So remember that. Then in programming, standard algorithm should be extensible. It means if the amount of your data increases, your algorithm should still work. So you should not use hard-coded numbers there, okay. But yeah, use the length function, things like that. Now for pseudocode, now in programming languages, you will have just different things. So see here, 4 position from 0 to 4. See, this is hard coded. This works for 4 elements, but if the data increases to 40, this will just not work, okay, very well. But using the length function ensures the loop dynamically adapts to any list data size. See, so length list. Now, if the list increases, length of list will just return the new length, okay? So doesn't matter if our data changes or not, this will always work. So that is just another exam tip. Okay, some questions here for practice. Okay, some exam style questions. The first one, define a recursive method. So a recursive method is a function that calls itself until a required goal is met. So it will keep calling itself till a goal is met. Okay. Question number 2, trace the first complete pass of a bubble sort for the array. So see here, it is just telling us to trace one pass. It means you have to show the steps. Okay. So if that is our main data, see here, step 1. So 4 in 1 or compared. So there is a sort needed. Okay. So that is just one step, the first step. Then in the next step, again, 2 and 4 are just compared. Okay. So 2 and 4 as well, they change, 4 and 2 are just compared and they need a swap. So a swap happens here. Then after that, 4 and 6. So no swap needed, okay? So the data does not change. Then after that, 6 and 3 are compared. So that will be 3 and 6, okay? A swap is needed there. Then 6 and 5. So a swap is needed. So 6 will just change the position, okay? So that is each steps of the pass 1. So at the end, we have gotten this 6, okay? That is in the correct position. Now for other elements, again, to be sure that, yeah, they are in their correct position, I will have to start again from first, okay? But this question asks us only one pass. The next question, a school needs to sort 500,000 student records. Justify which algorithm they should use and state the hardware drawback of this choice. So merge sort is faster. So yeah, they should just create merge sort, okay? And yeah, here, because they have just asked justification, you can just write the area because merge sort because it works much faster, and hardware drawback because it needs to copy the data in dividing stage, so or in dividing the data into smaller parts, so it needs more memory. Okay, so that is just kind of the hardware drawback. So that's it. Okay, wish you all the best. Good luck and goodbye. Do not forget to like and subscribe our channel and introduce us to your friends who are going to get this exam.